Assalamu alaikum students. I hope all of you are fine. I am your computer teacher Aisha Anwar. In this chapter we have studied about system development life cycle, and in previous lecture we studied about its phases. We discussed that there are about 10 phases of SDLC. Out of those 10 we discussed first 4 in the previous lecture. Today we will revise first 4 phases and will study next few phases of SDLC. Okay, first of all, let's revise SDLC. What is SDLC? It is a process that produces software with the highest quality and lowest cost in the shortest time possible. It provides a well-structured flow of phases that help an organization to quickly produce high-quality software which is well tested and ready for the use. Its basic purpose is to produce cost-effective and well-tested software. It has 10 phases. These include defining problem, planning, feasibility study, analysis, requirement engineering, design, coding, testing or verification, deployment or implementation, and in the end maintenance or support. In previous lecture we discussed first 4 phases of this SDLC from defining problem to analysis. Today we will cover requirement engineering and designing. Requirement engineering phase is further divided into 3 phases: requirement gathering, requirement validation, and requirement verification. And design phase is also composed of 2 phases. Further, in designing we make, first of all we write algorithms, and secondly we make flowcharts. So today we will study in detail about algorithm and flowchart during the designing phase. Okay, first of all let's revise first 4 phases. Okay, here is the detailed diagram of SDLC. You can see that it is a step-by-step procedure. From one phase you can move towards the other phase. After completing the second stage, then you can go to the third stage. Similarly, it is the same case in all the stages. And if you see, from the last stage, that is maintenance, you can go back to the defining. It means if there is any maintenance required for that system, we have to start from the very first phase so that we can address the issue in a well defined and well organized way. Defining phase. In this phase, the problem to be solved or system to be defined is to be developed is clearly defined, which means that each and every requirement or specification of the system is clearly mentioned during this phase. You can relate the name defining with its detailed activities, what type of activities can be performed. Defining means we are going to document and we will get approved that document from the customer, that what are the customer requirements that are to be designed and implemented into a particular system. After designing phase, we will move towards the planning phase. In planning phase, objective of the project is defined and determined. All the resources that are to be used are estimated in terms of cost, in terms of person, along with the concepts, and all the information is analyzed to see if more than one solutions exist. If there exist more than one solutions, we will go for these solutions one by one and will find out the best solution that is possible. After planning, we will move towards the feasibility study. In feasibility study, we look for the strengths and weaknesses of the system. What are the strengths of the proposed system and what are the weaknesses of the proposed system? We do the we perform this feasibility study on the following circumstances that are technical, economic, operational, legal and schedule. We study a project should be technically feasible, economically feasible, operationally feasible, legally feasible, and it should be feasible schedule wise, means it should take a particular time period, it should not take years and years. After feasibility, the analysis phase comes. In analysis phase, the project team determines the end user requirements. Often this is done with the assistance of client focus groups, which provide an explanation of their needs. To meet the analysis phase, the team asks some questions from the customer, and these questions can be like, can the proposed software system be developed with available resources and budget? Will this system significantly improve the organization? Does the existing system even need to be replaced or not? Maybe there is no requirement to replace the current system. The example that we are discussing is about the examination system. In analysis phase, the project team may visit the school or college or university or the organization about which the software is to be required to study the existing system and will suggest the possible improvements in existing system. After this analysis phase, the next phase is requirement engineering. As its name indicates that we will be gathering requirements in this phase. Requirement engineering is the process of defining, documenting and maintaining the requirements. It is a process of gathering and defining service provided by the system. It means we have to identify all the requirements of the customer. Requirement engineering is basically the set of activities. Using those activities, we identify the requirements, that what is to be integrated into the system. Requirement engineering consists of 3 steps: requirement gathering, requirement validation and requirement management. Through these 3 phases, at the end we will be having a set of perfect requirements that are to be integrated into the system. While performing requirement engineering activities, first of all we will gather the requirements. In requirement gathering, it is usually the first part or the first phase of any software or system development. Through different meetings that are arranged with the customers, requirements are gathered. There are basically 2 types of requirements that are gathered: functional requirements and number 2, non-functional requirements. In functional requirements, we specify the software functionality that developers must build into the system. फॉर एग्ज़ाम्पल कि किसी एक सिस्टम में कौन कौन से फंक्शंस या कौन कौन से फीचर्स होने चाहिए, ऐसे तमाम रिक्वायरमेंट्स को हम फंक्शनल रिक्वायरमेंट्स कहेंगे. इन नॉन फंक्शनल रिक्वायरमेंट्स दे डिफाइन द criteria for the judgment of the operations of the system. नॉन फंक्शनल रिक्वायरमेंट्स में वो रिक्वायरमेंट्स आएंगी जिनके थ्रू हम फंक्शनल रिक्वायरमेंट्स को चेक करेंगे वेदर दे हैव बीन मीटिंग द कस्टमर्स रिक्वायरमेंट और नॉट. आई एम रिपीटिंग दिस. Functional requirement is the set of requirements which specify the software functionality कि जो सिस्टम हमने बनाना है उस सिस्टम में क्या क्या फंक्शंस होंगे. दिस इज़ फंक्शनल रिक्वायरमेंट. अब किसी रिक्वायरमेंट को किस तरह से चेक करना है, उसकी चेकिंग का जो क्राइटेरिया होगा, that criteria is the non-functional requirement. It describes that how well the system performs its duties. So in the phase of requirement gathering, both functional and non-functional requirements are defined. After this phase, requirement validation comes. In requirement validation, we examine the requirement to certify that they meet the intentions of the stakeholder. It means कि जितने भी रिक्वायरमेंट्स को मेंशन किया गया है उनको हम चेक करेंगे कि वेदर दे आर मीटिंग दी कस्टमर्स नीड और नॉट. द वैलिडेशन डिफर्स फ्रॉम वेरिफिकेशन in the sense that verification occurs after requirements have been accepted. It means that requirements आने के बाद, requirements को verify करने के बाद, we will go through this phase. In requirement validation, requirements elicited are reviewed to check that requirements are complete and accurate. Elicited means all the requirements that have been highlighted or that have been given by the customers or that are defined by the customers. जो set of requirements आया है उसको review किया जाएगा कि whether these requirements are complete and accurate. If some requirements are left, then developers or the team may go for another meeting with the customer to get the complete requirements. After the validation, the management of requirements are performed. Requirement management is performed to ensure that the software continues to meet the expectations. It means कि रिक्वायरमेंट मैनेजमेंट फ़ेज़ में रिक्वायरमेंट्स को अच्छे तरीके से मैनेज किया जाएगा और इस चीज़ को इंश्योर किया जाएगा कि जो भी रिक्वायरमेंट्स आई हैं एट द एंड ऑफ द सिस्टम वो ठीक तरह से सिस्टम में इंटीग्रेट कर दी गई हों. अगर प्रोजेक्ट टीम इस चीज़ को समझेगी कि ये रिक्वायरमेंट्स अभी काफ़ी नहीं हैं तो दे मे फाइंड अ नीड टू गैदर न्यू रिक्वायरमेंट्स from the changing expectations due to new rules and regulations of the organization and due to the change of any sources that are related to the system. For example, in students examination system, the development team will gather the necessary information by interviewing the users. जो users होंगे उस examination system का उनको interview करेंगे, उनको क्वेश्चनर्स दिए जाएंगे और बाय रीडिंग दी एग्जिस्टिंग डॉक्यूमेंट्स या जो डॉक्यूमेंट्स उस सिस्टम से रिलेटेड हैं उनको स्टडी करेंगे. उनको स्टडी करने के बाद दे विल चेक आइदर द रिक्वायरमेंट्स आर कंप्लीट, सफिशिएंट एंड एक्यूरेट एज वेल. सो व्हेन दीज थ्री phases are performed, requirement engineering phase is completed. After the phase of requirement engineering, the design phase comes. Once all the requirements are gathered and checked and verified and managed, we have to now design the system. The design phase is basically the architectural phase of the system. In this phase, we are actually defining or building the system into the papers. The flow of data processing is developed into charts and the project team determines the most logical design of the structure for the data flow and storage. In this phase, different charts are to be developed, algorithms are to be written and the mock-up screen layouts are developed. Mock-up means trial screen layouts. Mock-up means fake. So it means trial screen layouts are developed to check whether this system is integrating all the requirements or not. Design phase usually goes through by writing algorithms and making flowcharts of the written algorithms. The students who have studied computer science in metric, they have a better understanding of algorithms and flowcharts. Let's revise them again. So what is an algorithm? Algorithm is a specific step-by-step procedure to carry out the solution of a problem. जो भी हमारा solution होगा उसको step by step form में लिखना जो है, that is the algorithm. For example, first step we will write start, then we will read the marks. User will enter the marks and we will read the marks. If marks are greater than or equal to 40, then print pass, else print fail, and our program will end. So it means it is a short algorithm to check whether a student is passed or fail in a particular subject. So algorithms are written in English language. They are written in steps like 1, 2, 3, 4 and so on. If some various steps are required, we will write down each and every step, and if there is a requirement to repeat some steps, we will repeat. The process of converting those algorithm into the diagram form is known as the flowcharting. We convert the written algorithm that is written into the English language, we convert that algorithm into the form of a diagram using some specific shapes is known as the flowchart. So a flowchart is a type of diagram that represents the algorithm or the process. The steps of algorithms are shown with the help of boxes, some specific shapes, and their order is defined by the arrowheads. So we can say that it is the diagrammatic representation of algorithm that gives a step-by-step solution. The flowcharts are helpful for analyzing, designing, documenting or managing the complete process. For example, here are the symbols used for making the flowchart. First of all, we will use the oval shape to indicate the start and the end of the algorithm. Whenever we have to specify input and output operations, we use this parallelogram. Whenever we are intended to show some processing, for example some calculation, some computation, we will use the rectangle shape. The flow lines are used to connect the two symbols or simply they show the flow of data. Diamond shape is used to represent some decision structures. Decision structures mean some conditions. For example, we have discussed a condition if marks are greater than or equal to 40. So this is a condition. This type of conditions are used in diamond shape, and in the end a small circle is used as a connector. This connector is used to join the algorithms, basically flow of a diagram. Now here if we can see in detail the algorithm for the algorithm that we discussed, here is a flow chart for that algorithm. We will go through it. First of all, start, then we are taking the marks from the end user as input, as it is input, so that's why we have used this parallelogram shape. Now we are checking over the marks. If marks are greater than or equal to 40, if yes, then print pass, if no, then print fail, and after checking both of these conditions it will be stop. Now have a look in one screen. First of all, start, we are reading marks from the user. Your system will be asking for the marks. Please enter the marks in computer. User will enter the marks. Now system is checking for the condition. If marks are greater than 40, if this condition is true, then simply it will print pass and will end. If marks are not greater than 40, for example, if I enter 20, it will check if 20 is greater than or equal to 40. If this condition is false, then simply it will print fail and will stop. As you can see that there are 3 parallelograms are used in this flowchart because it is input and the rest 2 are the outputs. As we have discussed, for inputs and output we use the parallelogram. That's all for today. You have to revise all these phases from the defining problem to the designing phase, and in designing revise its 2 phases, that is algorithm and flow charting. In next lecture we will revise these phases and we will cover few more phases of SDLC. Thank you.